trying to record it for the fifth time actually, but oh well. Hello, this is Wilson. I'm recording from McDonald's. This week I haven't done much OSSU related work because I have been busy with doing discrete math. And honestly, I've been finding this discrete math more interesting than what I'm doing, more interesting than the programming related stuff that I'm doing. Both the how to design data, more interesting than how to design data, how to design functions, and also more interesting than the SAS I'm making. But math, like very pure, very abstract math, is not very useful in the real world. And a lot of math majors, they do like software engineering and they work in finance. They do something like actuarial science. So I've been doing discrete math from this book, Busby, Coleman, and Ross. The book is called Discrete Mathematical Structures. There's also another good introductory book by Susanna Epp called Discrete Math, and that is better because it has more examples, and it's got a lot of like practice questions in examples. Here it gives you a lot of examples. There's like an info dump, but it doesn't ask you questions, so it doesn't consolidate the things that you learn here. Most math books are structured in this way, like there are a lot of examples, then you have questions. In school I really hated math because like school math is just garbage. Like they just give you some questions, and like I said, you can't teach math, like you can't teach programming. It's these two things, like you have to practice them, and like those math tuitions are really stupid. I don't know why people do them. I don't know why people teach math. Maybe teaching does help, but I think you have to just get used to it, like von Neumann said. So, and I really enjoy practicing it, but like I said, it has very little practical use, and at some point it gets so abstract that you need math to describe math. And what I mean by that is that so here you have a question. In each part, give the set letters in each word by listing the elements of the set. Now basically you just have to identify unique letters in this. So in Ardour it could be A, R, D, V, and yeah, that's it. And in book it would be B, O, and K. But these three things, Ardour, book, and Mississippi, we have like there's a real concrete object about it in the world, similar to this kind of thing. Ada, basic, Pascal, and Ada. There's a similar. There are like real objects in the world which we could point to, but this kind of thing, like x is a real number and x squared minus 1 is equals to 0. So x is an element of x, and x is a real number, and x squared minus 1 is equal to 0. This kind of thing is just very abstract, and that math gets so abstract at that level that you can only describe it with math. So yeah, so that's why it doesn't have that many practical uses. But like it's used in physics, it's used in computer science, and it's used in engineering. It's just unparalleled. And discrete math is different from continuous math. Continuous math, you have like decimals and all those things. It's a very crude definition, and discrete math you have like whole numbers like 1, 2, 3. It's a very crude definition, but yeah, that's basically the difference. But I'm sure many of you might know the difference anyway. But I would not recommend you to pick up a book and just start reading it. What I would recommend is that you actually go to the course, like here you have like Maths for Computer Science. You actually go to the course website and you look at their course. You just do view course, and you first read this, and then you start to practice them, and then you pick up a book like this. Or you could do a little bit of practice from here, then do that, but keep that curriculum in mind. I think the way math works is that you have all of this extra knowledge, extra practice that you do, and this is just again a crude example. In like Khan Academy I should also like draw things, but let's just assume this is all the math you practice from books like these, and then this is like this sphere that you see is the math that you have to do to pass an exam. or it might be this B, or it might be this C. Actually, when you think about it, this is the kind of math that you need to like get an A, and then this is a math that you need to get a B, and then C, I don't know, C is just irrelevant, like forget it for now. Or maybe like this small intersection of it, C is like the fail level math that you do, like you fail to do the A and you fail to do the B, and so you are at here. But what I'm trying to do is I'm trying to do this level of math and try to screw my life, and I wouldn't do that. I would do the racket question and then make more progress with OSSU. I'm looking for a place to live now because, like I said, I was homeless before. So hopefully I find something to live, and then I could focus more on this. It's been a difficult journey doing this. And although I find math interesting, I feel I should just put my head down, put the nose to the grindstone, do computer science, finish computer science, because there's a lot of time left later to do things like this kind of math. And I can't be a mathematician now, and even if I do become a mathematician, I won't contribute something significant. But anyway, math is more interesting, but don't go crazy with it. And I will post more videos related to OSSU. And what I would say is that I will persist with it, and hopefully I finish it. And this whole thing documents my whole journey. It would be good to make like high quality videos, but the sad thing is that on YouTube, like gaming videos, those kind of videos get more traction, or finance videos, how to make money easily. I don't know how like people like Travesty Media and like a Free Code Camp, people like that just like stand out from the crowd, because no one's interested in programming. It's all about easy finance, making money, or like just watching Fortnite. But anyway, like and subscribe, stay tuned for more, consider donating through PayPal, and peace out.